Welcome to my channel. Today I will be diving into a simple and effective framework to help you understand any problem in less than 15 seconds. So, whether you are tackling coding challenges, algorithm puzzles, or everyday logical problems, the Pearl framework is your go to tool. So, let's jump right in. Pearl stands for problem understanding, examples, approach, reasoning, and logic. By following these 5 steps, you can quickly break down complex problems into manageable pieces and find a clear solution. Let's walk through each steps with an example problem to see how it works. So the first part is problem understanding. So start by clearly defining the problem and its requirements. Just for an example, let's say you are given an array of ratings representing children in a line. The task is to distribute candies such that each child gets at least one candy, and the children with higher ratings get more candies than their neighbors. So remember, the goal is to minimize the total number of candies distributed while meeting these conditions. Let's go to examples. So let's look at some examples to understand the problem better. For instance, if the ratings are 1, 0, 2, the optimal candy distribution would be 2, 1, 2, totaling 5 candies. Another example is ratings 1, 2, 2, where the distribution should be 1, 2, 1, totaling 4 candies. So example like these helps you to see the pattern and test your understanding of the problem. Let's come to step number 3, approach. Now let's outline a step-by-step approach to solve the problem. First, initialize each child's candy count to 1, as every child must get at least one candy. Then do a left to right pass. If a child has a higher rating than the previous child, give them more candies. Next to right to left pass to ensure that each child with a higher rating than their next neighbor also has more candies. This two-pass strategy ensures all conditions are met with minimal adjustments. Step number 4, which is reasoning. Here is the critical step. Check your reasoning to ensure your approach covers all conditions. For example, after the first pass from left to right, you might not fully satisfy the conditions for the right neighbor. The second pass from right to left corrects any discrepancies, ensuring every child's candy count is accurate based on their neighbors. Always verify that your approach handles all edge cases and scenarios presented in the examples. Now go to the step 5, which is like a logical algorithm. Finally, translate your approach into a code. So here is the simple Python implementation for the candy distribution problem. So you define a function with the name def candy, then you're passing a variable called ratings. Then the next step inside that function is that you are calculating the length of that rating. So by using a variable called n is equal to len ratings, and then you are initializing a variable called candy, which has a multiplier of 1 into n. Now we'll do left to right pass. So for that we would be running a for loop for I in range 1 comma n. If rating I is greater than rating I minus 1, candies at I will be having more candies at I minus 1 location plus 1. For second pass, we'll do right to left. So in that, for I in range, we'll go for n minus 2 minus 1 comma minus 1. So if rating I is greater than rating I plus 1, candies I will be the max of candies I or either candies I plus 1. And then we return those sum of candies. So this solution is efficient with a time complexity of O(n), making it suitable even for large inputs. So in a conclusion, by using the P.E.A.R.L framework, you can break down problems, understand the requirements, develop a plan, verify your reasoning, and implement the solution quickly and effectively. Remember, the key is to keep each step simple and focused, ensuring that every condition is met. So if you find this guide helpful, do not forget to like, subscribe, and hit the notification bell for more problem solving strategies and coding tips. Thanks for watching and listening, and see you in the next video.